Hi, today we are going to talk about vectors. This video assumes you have already reviewed the video on arrays. Now let's get started. Why would anyone want to use vectors over arrays? Which one is better? Well, I did a Google search on arrays versus vectors, and I've got a few hits here. If we look at the second one here, stackoverflow.com, which is a good site to use also. C++ is probably the best site to use. I would use stackoverflow.com as another site. But if I click this and I scroll down here, here are some advantages to use vectors versus arrays. The first bullet entry is important, but it's technical and does not concern us. The second one is that they aren't a pointer in disguise, which arrays are pointers in disguise, and we'll learn about pointers in a subsequent chapter. Vectors can also increase or decrease in size at runtime. Arrays cannot. You have got to specify your array size before you compile. Vectors also do range checking. Remember I said you can access outside of the array. If we look at our example here, we could access this from the array, but that is really out of bounds. We can technically do that. With vectors, you don't have that chance. Vectors, you want to use the @. I'll show you an example of that. A vector knows its size, so you don't have to count the elements. You don't have to be sure you know where the last element is. Vectors will always know. In review, arrays have some shortcomings. Before we go to the code, I'd like to look at the documentation on what a vector is and what all the functions we can do and perform with a vector. So all I did was type in vector C++ in Google, and my first hit is cplus.com, which is probably one of the best resources we can use. I'm going to click on that, and it discusses what a vector is. I'm mainly concerned with all the functions we can do with a vector. So we can do all these functions. We are not going to use them all, but we will be most concerned with this one, vector @. And this one gets an element at a certain index. Okay, you can read about how to use it and what it returns here. We were going to use pushback and popback. Pushback will add an element at the end of the vector, and popback will remove the last element of the vector. Another important one we will use is size. The size of the vector is easily gotten by using the .size function, and we will see that in the code. So basically we're going to be working with size, pushback, popback, @, and let's see if anything else we're going to use. Not much more, but we have all these functions we can use. So if you ever want to do an action to a vector, please search in C++ for what all functions we have available to us. Now when we look at the code, one thing with vectors, you need to include a library called vector. Otherwise you won't be able to use vectors. In this program I'm utilizing functions. We will get into functions in a subsequent chapter, but I do use them here, and I will go over what this is doing right here because this is important. But other than that, I'm not going to go into the function. Here is our main program. The first thing I do is I declare a student's vector. The way you declare a vector is the keyword vector, open bracket, angular bracket, that is, the type that's going to be stored in this vector, close angular bracket, and the vector name. So in this vector I'm going to store names of students, very appropriately named. I'm going to just get the size of the vector when I declare it, just to show you. And I use students.size. Then I'm doing the pushback, simply pushing back a string. And what this is doing, this is saying location sub 0 gets Homer, location sub 1 gets Marge, 2 gets Bart, location sub 3 gets Lisa, and location sub 4 gets Maggie. I'm getting the size a second time. I'm printing out the size. So the size is now 5 because I've pushed 5 names. Here is the at function. So I'm getting the student at index sub 3. Homer 0, Marge is 1, Bart is 2, Lisa is 3. So this will return Lisa. I then am declaring another vector called scores, and this vector can only store doubles. In this for loop, I am just going from index 0 to the size of the student vector. In this case there's 5, and I'm pushing 5 doubles, or 5 floating point numbers. Just for fun, I'm adding one more name and one more grade. When I get down here, I call this function called print student scores. I'm going to use the student vector, the scores vector, and students.size, the size of the students vector. Now remember we talked earlier about parallel arrays. Well, there's no reason I can't do parallel vectors, which is what I'm doing here. So I'm having two vectors, names and grades, and each vector corresponded by an index will return the grade of that particular student at that same index. So let's run this program and see what happens. I'm going to press F5, so I'm debugging. We are at this location right here. Let's bring up what we got here. Initially, the size was 0. We added 5 names. We're now the size of 5. So I'm going to step and students at 3 is Lisa. If we look down here, we can see our students vector. It has a current size of 5, and the third element is Lisa. So that's why you got this value. I'm going to set a breakpoint in this for loop. I've just declared a vector of doubles called scores. Now if we look at our scores vector, currently the size is 0. I'm going to add scores for all 5 students. And I'm adding another student and another grade. So now we have a total of 6 students, Peter being the last one entered, and we have 6 scores. 0 corresponds to Homer's score, and 95 corresponds to Peter's score. I'm going to continue now. It's going to hit my breakpoint in the function. So I have the student score, I have the student vector, and I have the grades vector, and I have the size of the student vector. So all I'm doing is going through the vectors, and I'm specifying the name of that student and the grade. Notice here I'm using at, which is 4 vectors. I can just as easily use open bracket I, the value that I want, the index that I want. Now this is the same thing arrays do, but that is not preferred when you're working with vectors. With vectors, you want to use the dot at. Some error checking is done for you when you use the at function, so please, with the vectors, use the dot at function and not the open bracket index and the close bracket. So let's step through this. Okay, I modified something. Let's break out of this. I modified the code here, so we got to stop and rerun. So let's rerun our code. Let me back up. Anytime you modify code when you're currently debugging, you have to rerun the program because your modifications are not known to the compiler. Anytime you make modifications to the code when you are currently in the debugger, those modifications are not known to the debugger because the debugger was using the original code that you compiled and not the new code. So you have to exit and restart the program, which is what I'm doing now. Going to click F5, and let's click F5 again, and one more time, and I should hit the breakpoint in my loop here, which I have. Okay, so I have students by and grades by. So basically I'm going through the vectors and I'm just listing the student name and the grade. Let's step through here. Okay, that's the first one. So we can look at the first student. So student sub 0 is Homer and his grade is 0. Let's step again. I have to step one more time. Student sub 1 is Mars, the grade is 10. And let's set the breakpoint here now. We will continue and we will look at our output. So we have 6 students and 6 grades. This is vector students, this is vector grades. Now if we step back, we come back to our main program, and this is basically all I wanted to discuss with vectors. So this concludes the video on vectors.